Greetings and welcome once again to my new calculus channel. And today I'm going to address a very important question that was asked by one of my viewers who's actually thinking about the content, unlike most of you who don't think about it. So let's begin. The video was this one here on the famous constant pi, square root 2, phi, and e. Okay, and you should actually watch it because there's a lot in there that you don't know or understand. And the picture of the video is this one here. It says the famous constants pi, square root 2, phi, and e. Okay, so I'm just going to go quickly over the back and forth. So he says, wait, are they called constants because the ratios between the measured magnitudes remain constant, irrespective of where the magnitudes in terms of the abstract unit? In other words, a constant doesn't represent a constant number, but rather a constant ratio proportion. So this guy's thinking, and I did answer him. I said, yes, that's what they represent, okay? And a constant doesn't represent a constant number, but rather a constant ratio proportion. No, it represents a number from a failed attempt at measuring a constant ratio or proportion. And then he says, so if constants can never be rational numbers and never be accurately represented in algebra, then why does algebra use them in equations with numbers? Does that mean any equation using a constant can never get a true answer? And so here's the response. So I said, algebra treats, and let's just go to a big version of this. I said, algebra treats everything as rational numbers, okay? Everything. Algebra doesn't know anything but rational numbers. Those mythical objects that they tell you about in university and school, real numbers, don't exist. They're garbage, 100% garbage. There's no such thing as a real number or a real number line, and most of their misguided understanding is based on a number line, a real number line that cannot be reified. So when algebra, let's say, sees the symbols, only the coefficient of the symbol is used. So for example, if you have 2x plus 3 is equal to 5, to algebra, that is the same as 2 pi plus 3 is equal to 5 when it manipulates pi and x, okay? It manipulates them exactly the same way as placeholders, okay? So it manipulates x and pi as placeholders because that's what they are, placeholders, not constant, not variables or other garbage that you hear your teacher tell you. They're not variables, by the way. Okay, and then he says, and then of course he says, does that mean that any equation using a constant can never get a true answer? Yes, because if you solve, for example, if you solve 2 pi, let me make this window bigger. Okay, if you solve 2 pi x plus 3 is equal to 5, what are you going to get? Let's take the 3 over, then you'll have 2 pi x is equal to 2, which means pi x is equal to 1, which means x is equal to 1 over pi, okay? So as you can see, algebra treats x and pi exactly the same way. But over here, it assumes that you need to find x in terms of pi, okay? But it doesn't know anything about pi except that it's a placeholder. And that's how you get this answer, x is equal to 1 over pi, because you're solving, if you had to solve for, here's the gist of it. Here's the irony. If you had to instead solve for pi instead of x, watch what happens. So let's say you said 2 pi x plus 3 is equal to 5, right? And you're solving for pi. So you'd have 2 pi x is equal to 2, divide by 2, pi x is equal to 1. So pi is equal to 1 over x. Can you see? 1 over x and 1 over pi. Treats them exactly the same way, but your moronic mathematics teachers are all a bunch of incompetent, stupid, jealous, psychopathic morons like your mainstream math professors don't understand these things and never have. So 1 over pi is never anything but a rational number to algebra. To wit, when you replace pi by 3 or 3.1 or 3.4 or 3.1414 or 3.14159 or any other approximation, 1 over pi will still be a rational number to algebra, you moron, and it will be approximated that way. Okay, it will be used exactly as a rational number because algebra uses the abstract unit. And in algebra, a ratio without quotientness cannot be measured. All it does in algebra is takes the failed approximation. Okay, so for final comment, the word rational is redundant in front of any number. Okay, because number implies rationality and vice versa. And one might say, oh, it's more accurate to write pi. No, it's not. It's more meaningful to write 1 over 3 or 1 over 3.1 or 1 over 3.14159, etc., because pi by itself is just a placeholder, okay? A placeholder for a constant, which you cannot measure. So I'm going to be recommending 3 articles for you to read, okay? And the one is called Realization of the Number Concept. The other one is called Arithmetic Without Numbers. And the next one is a free ebook. You better read all of those. If you're not already a subscriber, become a subscriber. I do know better than anyone else. Yes, I know better than you, moron. Click like, follow me on Academia, and I'll be chatting to you soon. Goodbye.